All right, here we are. The question is, how do you find the domain of and graph a square root function? So I've given an example of a square root function here. F of x is equal to the square root of 10 minus 2x. And we just want to find the domain and then graph it. So first of all, about domain. I've got an example of this elsewhere in the YouTube channel, but just to reiterate what's there, the domain of a function is first and foremost a set. It's not a single number. It's not a single variable. It's not an expression. It's a set. It's a whole collection of numbers. It's the set of all legal inputs to our function. And typically, if we use x to represent the variable that we're inputting into our function, we're talking about the set of all x's that we can put into this function that give us a valid output. Now, what makes an output valid? An output is valid if the output is a real number. So it's those x's for which f of x is a real number. And remember, real numbers can be positive, they can be negative, they can be integers, they can be fractions, they can be rational numbers, they can be irrational numbers, they can be transcendental numbers, but they cannot be complex, right? The one thing that, let's say the two things that we are not allowed to do with real numbers. So these are the, let's call them the two deadly sins for our course. These two operations both produce non-real values. So the two things that we want to be on the lookout for that produce non-real values are to take the square root, or actually really any even index root of something which is negative. And then the other thing to look out for is division where the divisor is 0. So those are the two things that we are not permitted to do. We can't take the square root of a negative quantity, and we can't divide by 0. There are other impossibilities as well that you might talk about in pre-calculus, but for our course, those are the two things that we need to be on the lookout for. So if I want to know what the domain of this function is, I need to answer the question, how do I make sure that what's underneath the square root is not negative? In other words, I want to find all the values of x for which that thing underneath the square root is non-negative. If I can describe that set, then I have described the domain of my function. And that gives away the farm here. It tells us that to find this domain, what I need to do is take that expression underneath the radical and insist that it be greater than or equal to 0. And then solve that expression, solve that inequality for x by subtracting 10 from both sides to give me negative 2x is greater than or equal to negative 10. And then dividing by negative 2 on the top and the bottom. And that gives me an inequality which hopefully answers our question. That has an x on the left-hand side. Negative 10 divided by negative 2 is positive 5. But take note that we've divided by a negative number here. And because I've divided by a negative number, the sense of my inequality has to flip. So I'll move it around to less than or equal to. So the domain of our function in this example is the set of all x's that are less than or equal to 5. Let me quickly, on our graph paper, indicate what that looks like. So the point where x is equal to 5 is right here on the x-axis. Let's say, right? Then the domain is going to be the set of all x values that are to the left of that point. And so our graph, when we sketch our graph, is going to lie just above or possibly below that piece of the x-axis. There's going to be no graph to the right of where that domain ends. That also suggests to us what interval notation might look like for this domain, because we have no leftmost extreme. Negative infinity is going to be the left endpoint of our interval. And our right-hand endpoint is 5. And we're including 5 as part of our solution because x is less than or equal to 5. So I'm going to use a square bracket on the 5 to include it, a round parenthesis on the minus infinity to exclude it. And then there's the domain of this square root function expressed in interval notation.